All right, if you're not quite done doing Descartes' rule of signs on the first two examples here, that's fine. We'll just go through it here quick just to get that done. Again, it was me kind of getting you started off here. Remember, to find the positives, all you have to do is count sign changes. So, yeah, yep, yep. Now, if you read the directions, it explains what that 4 is at the end. Basically, it's saying given a function and one of its zeros. So basically, it gave you one of the answers. So 4 is one of the answers here. It says find all the other zeros. But what I want you to do is do this so I can show you how it all relates. And so we know as far as positives, there are 3 potential, correct? But if there's 3, there is also the potential to only have 1. Because remember, you always go down by 2 until it makes no sense, right? And having a negative number of positive roots makes no sense. So you don't go to -1, right? But it does. You have to go down by 2. Now to do negatives, you're going to get quicker at it. I kind of look at this and know it's going to end up negative if I put negative x in there. If I put negative x in here, I square it, it becomes positive. So this whole thing just stays negative, right? This term becomes negative. That one stays negative, right? Some of you probably do that already, which is fine. You just kind of, it doesn't take as much time. So is that correct? Let's take a look. Is this going to end up negative? Yep, this first term in. How about this one? Does that one end up negative? Yep. This one here, does that one end up negative? And does that one just stay negative? Okay, so what about sign changes? Well, there aren't any, all right? And let's face it, we should have probably knew that when 3 of them were already positive and there's only 3 total. We should have probably seen that coming, all right? So we know there's a 0 there, right? But remember, when you start a column with a 1 or a 0, if that's the first thing you put in there, you just put it as many times as you need it. Because I know 0 is the only possibility, so we'll fill it in. So again, we're looking here and we know there are 3 possible. Okay, so 0 or 2, all right? And so then we got to figure out, well, what does that kind of look like? So I'll just do them up here because I'm going to run out of room otherwise. So 3 positive. So 1, 2, 3, and it's x to the 3rd, so it could look something like that. Or we just have 1 positive, so it could look something like that. At this point, do we know which one is going to happen? No. But by the time we're done with this one, we're going to be able to figure out which of those 2 is actually more accurate, which one actually has a better chance of being the correct answer. All right? So again, we're kind of starting in general, and we're going to narrow it down until we have it figured out perfectly. So are there any questions on Descartes' rule of signs there? No? All right. Now, it tells me in here that I have been given a function, and there it is. And I've been given one of its zeros, there it is. So I've been basically, they just gave me an answer. So if they've given me 1, how many are left to find? Yeah, if there's only 3 total and I've already been given 1, I've only got 2 more to find. Well, that's not so bad. So you notice that it's a real number that I gave you though, right? Those are nice and easy. Because all you have to do is go to synthetic and take out the 1 you know, and it'll leave you with the 2 you don't know, right? But here's what a lot of people do. They put a -4 in the box. That is incorrect. The 0 goes in the box. And if 4 is the 0, what should go in the box then? A 4. Because many of you are thinking of x minus 4 is always how they used to give it to you earlier in the chapter. So if x minus 4 is the factor, set that equal to 0 and 4 goes in there. Yes, was there a question? No? Okay. So 4 goes, do we have to worry about any zeros? Are we missing any? Let's see, 3, 2, 1, none. I think we're good, right? So 1, -6, 10, -8. And you know what's great about these? Is you have a built-in check. You know if you did it right. Because you know what one of these numbers should be. That remainder better be 0 or we did something seriously wrong. Right? So you start it off. Do you start it by bringing down the 4 or bringing down the 1? Yes, bring down the 1 is how you start synthetic. And then the splash effect. So 4 times 1 is? It's not a trick question. 4. Do you change your signs in synthetic? No. So it's a -6 and a +4. -2. -8. And you already told me you don't change your sign. So 10 and a -8 is a 2. Is this going to work out? Let's find out. 8 goes right there. Aha. Remainder of 0. So at this point, you should feel fairly confident that you have done it right. Okay. So it was x to the 3rd. right? One of them got taken out, so this must be x to the minus 2x plus 2. Now, the other two zeros are in there, right? Now I'm asking you to go find them. Does it say only go find the nice ones? Unfortunately, that's not what it says. It says go find them no matter what they are. And so we have to do that. When you have something that's x squared like this, you can always try key number factoring. And in here, it would have to multiply to be 2 and add to be negative 2. Is that going to work out for us? No. So wait a minute. Key number factoring doesn't work. Yeah, I heard somebody say it. Go to quadratic. Because it is quadratic, it's x squared. The quadratic formula is right there. Of course, we could go and complete the square because that's everybody's favorite way of solving these. Or we could just go to quadratic. And remember, this is A, B, C. Yes, I was being facetious. Completing the square is nobody's favorite, except for maybe mine. Yes, it is, because all the vowels are in it in order. I'll spell it for you later. It's okay. So here we go. So we have to take the opposite of b. Well, what is b in this particular problem? Be careful. It is a negative 2. See right here? It's a negative 2. All right. So what's the opposite of that? Is a positive 2. Now it says to take b, whatever it is, and square it. So I'm just going to write that out so we can see it. So take negative 2 and square it. Minus 4 times whatever a is, which happens to be, in this problem, 1. Times c, which happens to be 2. All divided by. That's where a lot of people actually make a mistake. It's the whole thing divided by, not just the radical, but everything. Divided by 2 times a, and a happens to be 1. Any questions where the quadratic came from? Again, we kind of had to go to that because key number wasn't going to work for us. Okay? And we were told to find all zeros, so we got to go. You know, we can't just say, oh, they're not nice, and go to the next problem. Right? That's kind of what we did earlier with factors, right? Ah, they're not nice. We'll just go to the next one. So we got to clean this up a little bit. Can we really do anything with this 2 out front right at the moment? Not really, because this radical actually counts as a grouping symbol, right? It says look in here first, take care of that. So it's 2 plus or minus. Well, negative 2 squared is 4 minus basically, do you see how that would be 8 if I multiply that out? Okay. All over, well, 2 times 1 is 2, correct? So we're almost there. I'm just going to change colors so that we can see that I'm writing something different, and we shall have to head in that direction. Okay. So x equals 2 plus or minus. And if I get going too fast, just let me know. Well, what is that? 4 minus 8 is, unfortunately, the square root of negative 4. Yeah, somebody said it. Here comes I. Because we dealt with imaginary numbers, right? That's why we did it before we did this particular section, to make sure that you knew. And basically, if I have the square root of negative 4, you break it down into the square root of negative 1 and the square root of 4. Well, what is the square root of negative 1? I. What's the square root of 4? We happen to know that one. It is 2. So you do agree that square root of negative 4 can get replaced with 2i. It's the same thing. Agreed? Okay. So x equals 2 plus or minus 2i. All I did was replace it. All divided by 2. Well, I'm asking you to remember a lot of stuff today, huh? Here's where a lot of people do all this work right, just to make a silly mistake at the end. When you get to a spot like this, I would look at it as basically having 3 locations. Here's a spot, there's a spot, there's a spot, right? Because there's plus or minus in there, right? If they all share this number at the bottom, or some factor of it, then you can cross it out of all of them. But if they don't all share it, you can't just pick and choose where you're going to cross it off. Do they all share at least some kind of factor of that number down there? Yeah, in fact, perfectly, right? So I can cross this 2 off and turn it into a 1. Cross that one off, turn it into a. Cross that one off, turn it into a. So the final answer is x equals 1. I'm sorry it's so low on the board, but there's a lot of work here. 1 plus or minus I. Are the other two zeros? What was the first one in the... yeah, 4 was the first one. 1 plus or minus I are the other two. Because it was x to the 3. You needed 3 pieces. Do I have all 3? Yeah, I have 1 plus I have 1 minus I, and I have 4. I have all the zeros. I have all of them. Now, obviously, I could just teach you, just do that, but now I want to relate it to what we did earlier. Up in black on the top right. I gave you 2 possibilities, correct? Which of those 2 possibilities is actually the one that is more accurate? Yes? Exactly, the one that has 2 imaginary, because what did we get? 2 imaginary. So this is probably a pretty good representation of what's going to happen for this problem. Does that TI-83 do it real nicely for you? Yeah, it does. But if you don't know where it's coming from, it doesn't matter. Because think about that. Somebody had to write that program at some point. Now, are they all going to have imaginaries? No, did this one have a chance of not having imaginaries? It did. It had a chance. It has 3, 0, 0. It had a shot. But unfortunately, we ended up with the bottom one. Okay. Any questions at any of those steps? Were there a lot of them? Yes, there were. Was any one of them beyond your ability? No. Putting them all together, can that be kind of difficult? Yes, it can. Okay. So let's take a look at another one. Let's just breeze through the this portion. Did you get 2 rows? Yep. I believe 1, 2, 0 and 1, 0, 2. Do you agree with my 2 rows of Descartes? And it is x to the 3rd. So what do we got here? 1 positive, 2 negative. And just basically 1 positive. One of those 2 is going to happen. If one of those 2 does not happen, either we did the rule of signs wrong or we did this other work wrong. But once again, notice I gave you a real number. If it's a real number, you can use, if you wish, synthetic. Okay? And what goes in the box? The 0 goes in the box. Is -2 the 0? Yes, it is. Put it in the box. So we got a 1, a 3, a -18, and a -40. Go ahead, finish synthetic real quick on your own. Great. As I was walking around, I see that we have a variety of people and a variety of spots. We have some people that are done with this problem completely, and we got some people that are kind of just starting their synthetic. So let's make sure that we follow along, make sure that we've got this going on, right? So you bring down the 1 and then splash effect again, the Fletcherism, -2, which leaves us with a 1. Now, we're kind of getting a little suspicious. We know we got to get all the way to 40, and this isn't looking so good right now, right? Because I just took that times that, and I only got a -2. But lucky enough that that actually ends up being a -20, gives me a +40, and we knew that had to be 0 because we were told that that number right there was a 0. It should be able to be divided out evenly. It was x to the 3rd, which means now I'm down to x squared. Now, what did we try first and it didn't work last time? We tried key number. Let's face it, is key number a possibility? Yeah, we've got 1 positive and 2 negative. So key number possibly could work. Okay, we're not stuck with knowing they're imaginary. What was it, number 5 today? You knew was imaginary on the worksheet. So on that one, I actually can't even give you that one because they're all 6 imaginary. There's no way for you to get there, right? So multiply to be -20 because you take those, right? And add to be 1. 5 and -4 is correct. Now, once again, I'm going to go through this factoring just to help people out. You bring this term down. You take these 2, and this one gets split into it. So plus 5x minus 4x. Because if I put those together, it is 1x. Okay? And then the -20 comes down. And squiggle. So x plus 5. So what has to be in parentheses over there? According to the way I have it set up, x plus 5 has to be over here. If I can't get it, we either did something wrong or you just can't key number factor this one. Can I get x plus 5 over there? Yeah, what do I have to take out? Negative 4 is correct. So the factors are x plus 5 and x minus 4. But that's not how we had our answers on the last problem. We just had the zeros. Was there any x involved with our answer on this last problem? Except x equals? It was x equals, not x minus or x plus, right? It was x equals that. So how do I get these to say x equals? Let's not forget, this is supposed to equal, or I want to know when this equals 0. So you can set each of those equal to 0 separately. If I set x plus 5 equal to 0, what value of x is going to make that happen? Negative 5, right? So x equals negative 5. What value of x is going to make this one say 0? The value that is 4. Wait a minute, how many answers was I supposed to get? 3. How many we got? We got negative 2, negative 5, positive 4. Okay. Now the question is, does that fit into Descartes' rule of signs? Does it? We said we were going to, one of the possibilities was 1 positive, 2 negative, and no imaginary. Did that happen? Yes, it did. There's a negative 2 and a negative 5. There's your 2 negatives and 1 positive. So this would probably be a better representation of this particular problem. So do you see how they don't all use quadratic and have to go through all that? Okay. Some of them, they come out fairly nice. Okay. So do you have any questions on the differences between the two or either one of them, just in general? No? Okay, I have a very simple one for you to add to the back. It is a slightly different problem, but it won't take you very long at all. It might take you longer to write it than it will to actually do it. All right, here we go. Hopefully that was enough time to have you write it down. So again, basically all those big words just mean keep it simple. But give me the polynomial that these would be answers to. Because basically back here, I gave you the polynomial and said go get the answers. Or go get the zeros. Now I'm saying, here's the zeros, go give me the polynomial. So what you do is you take these zeros and turn them into factors. And the easiest way to do that is you always go x minus whatever you're given. Because do you agree if I set x minus 3 and set it equal to 0, do I get the x value of 3 being the one that makes it work? See that? Does that make sense? So then you do the same thing here. X minus 4i. But there's a slight problem. Where do imaginaries technically come from? Where's the one time that we found it today? Where were we when we found that imaginary? We were working in quadratic, correct? And what's right in front of that radical in quadratic? A plus and a minus. So if you're ever given an imaginary zero, you automatically, without any discussion, are given its opposite. Only if they're imaginary. So 4i is imaginary, so you're automatically given negative 4i. So if I gave you 7i, you're automatically given negative 7i. If I gave you negative 2i, you're automatically given positive 2i. So then that one turns into It's really x minus a negative, right? So it's really x plus 4i. Now all you have to do is multiply it out. But I think two of them would be really smart to multiply first. Which two would be the smartest ones to multiply first? The last two. Because that's really that difference of two squares, right? Remember we kind of did that the other day? We multiplied those out. So let's do that. We'll do a different color. So what do we got there? That's x squared plus 4ix minus 4ix. Most people get those right. And seeing it is that difference of two square setup, the O and the I of FOIL will cancel every time if it is actually a difference of two square setup. A lot of people get this last one wrong, and then it throws off the entire rest of their problem. What do I have to take yet? Negative 4i times positive 4i is a negative 16i squared. Okay? I hope you agree that those two cancel each other out. And there's one more thing I can do before I mess with this x minus 3. Yeah, exactly. Get that I squared out of there. I squared is really just negative 1, right? But it's times. So really all of this together is x squared. And what does this end up being? Plus 16. Okay, so I'm going to write that up here. X squared plus 16. That's if I put two of them together, correct? But there are 3. So this better be x to the 3rd when we're done. So I have to now take this times the one I haven't dealt with yet, which is x minus 3. And that's just FOIL. Even though there's an x squared there, it doesn't matter, it's still FOIL. And look where our x to the 3rd comes from. Right there. X to the 3rd. I'm going to cheat a little bit because I want to put them in order as I go. I'm going to do this one next. You don't have to do that, but I'm going to cheat. Which one should you do next? Again, if you kind of want them in order, which one should you probably do next? The x and the 16 or the negative 3 and the 16? Yeah, the x and the 16 would be smart next, right? And then what's the only one left? That, which is? Yep, negative 40. Can you combine anything here? Nope. I guarantee you that if you started the process you just learned today on that, you would get 3, positive 4i, and negative 4i. You basically just took the answers and wrote them as a polynomial. Instead of being given a polynomial, find the answers. It's just the opposite. Okay? Any questions? No? All right.